Hi, today we'll be doing Summer 18, Paper 1-3. Let's start with number 1. First, what you want to do is to factorize out the 3 because you need a. We'll go ahead and factorize that. And perform the completing the square as you would normally. Remember to add 3 to the back. Now this will give you 3x minus 2 to the power of 2 plus 7 minus 3 multiplied by negative 2 squared. This will give you 3x minus 2 squared plus 7 minus 12. So you will get 3x minus 2 squared minus 5. Your numbers are a equals to 3, b equals to negative 2, and c is equal to negative 5. For number 2, what you want to do first is to find the numbers that will make 1 over x when you multiply them together. So it will be x squared multiplied by 1 over x cubed. So to find this, you will need to use combination, and that is what we'll do now. So in order to get 1 over x, you need to multiply 5c3 by x squared negative 2x cubed. The numbers here are the same, and that will give you negative 80 divided by x. So your coefficient is negative 80. For number 3, recall that in order to find the sum of the first 100 terms, you need the equation a1 minus r to the power of 100 divided by 1 minus r. In order to find the sum to infinity, you need the formula a divided by 1 minus r. Remember that you have to find the percentage of the sum to infinity. So it will be the sum of the first 100 terms divided by the sum to infinity multiplied by 100. For the sum of the first 100 terms, it will be a1 minus 0.99 to the power of 100 divided by 1 minus 0.99. And for the sum to infinity, you will have a over 1 minus 0.99. So the sum of the first 100 terms divided by the sum to infinity multiplied by 100 is equal to a1 minus 0.99, 100 divided by 1 minus 0.99. This will be divided by a divided by 1 minus 0.99. So you can cancel out the denominators because it will be the same, and you can also cancel out the a's. So what you have is 1 minus 0.99 to the power of 100 multiplied by 100. And this will give you 63.397%, which is technically 63%. A curve with the equation y equals to fx passes through the point A, 3, 1, and crosses the y-axis at b. It is given that the derivative of the function is, so find the y-coordinate of b. So what you need to do first is to integrate this derivative. So that will be 3x minus 1 dx, which is equal to half 3x minus 1 2/3 plus c. Now you will find the c using the point A. We'll write the equation with the y component. So y is equal to half 3x minus 1 2/3 plus c. Now we will substitute y with 1 and x with 3, and you will get 1 is equal to half 3 multiplied by 3 minus 1 2/3 plus c. And this will give you -1. Now your equation will be y is equal to half 3x minus 1 2/3 minus 1. Since it crosses the y-axis at b, you know that the x is equal to 0. So when x is equal to 0, your y will be 0 minus 1 2/3 minus 1. So your y is -1/2, and this is your final answer. The diagram shows a triangle OAB in which angle OAB is 90 degrees and OA is 5 centimeters. The arc AC is part of a circle with center O. The arc has length 6 centimeters and it meets OB at C. Find the area of the shaded region. What I want to find first is the angle AOC, which is this angle right here. And to do that, I will use the arc length of 6. So x over 360 multiplied by 2 pi 5 is equal to 6 centimeters. Your x will be 68.8 degrees. Now I want to find the area of sector AOC. To do that, you need the angle 68.8 divided by 360 multiplied by pi r square, which is 5 square. This is equal to 15 centimeters square. Now I will find the length of AB. I will show you the triangle. So I have 5 here. What I need is AB. That means I can use tangent x is equal to AB divided by 5. So AB is 12.86 centimeters. Next, I will find the area of the triangle using half multiplied by the breadth, which is 12.86075811 multiplied by 5, which is the radius or the height of the triangle, and this will give me 32.15 centimeters square. So the area of the shaded will be 32.15 centimeters minus 15 centimeters square, and this will give me 17.15 centimeters square or 17.2 centimeters square. The coordinates of point A and B are shown respectively, where K is a constant. So find and simplify the gradient of AB, showing that it is independent of K. To do this question, you need to first find the gradient of the AB, which is y2 minus y1 divided by x2 minus x1, and input your values. This will give you 2k plus 2 divided by 4k plus 4. And you can factorize the 2 for the top and 4 from the bottom. Since you have k plus 1 for both, you can cancel that out, so you have half. Rewrite this as the m of AB is equal to half. Find and simplify the equation of the perpendicular bisector of AB. Suppose that your point looks like this. This is A and this is B. This is only an example for reference. So your perpendicular bisector will be 90 degrees. This is the midpoint of AB, so you need to find the midpoint of AB first. So the midpoint of AB is k plus 3 minus k minus 1 divided by 2, and 3k plus 5 plus k plus 3 divided by 2. This will give you negative 2k plus 2 divided by 2 and 4k plus 8. And it's negative k plus 1 and 2k plus 4. Now, since it's a perpendicular bisector, you know that the gradient of AB multiplied by the gradient of the perpendicular bisector is equal to negative 1. So what you can do is to find the gradient of the perpendicular bisector. You know that the gradient of AB was half just now. And the answer is negative 2. So write your equation, y minus 2k plus 4, which is the y coordinate of the midpoint, is equal to negative 2 x minus negative k plus 1, which is the x coordinate, and you will get y is equal to negative 2x plus 6, or you can rewrite this as y plus 2x is equal to 6. Express that in the form of a sine squared theta plus b, where a and b are constants to be found. What you want to do first is to substitute the tangent squared theta with sine squared theta divided by cosine squared theta. This will give you sine squared divided by cos squared minus 1 divided by s squared divided by c squared plus 1. Whoops. This is equal to sine squared minus c squared divided by c squared. This is all divided by sine squared plus cosine squared divided by cosine squared. You can cancel the denominators out because this is division, so you will interchange this with this. So sine squared minus cosine squared divided by sine squared plus cosine squared. This is equal to 1, so you can just rewrite that simply as sine squared minus cosine squared. And remember that 1 minus sine squared is equal to cosine squared. So you can change the cosine squared as well. You will have sine squared minus 1 minus sine squared. This will give you 2 sine squared theta minus 1. For the second question, you can substitute the left-hand side of the equation with what you got earlier, which is 2 sine squared minus 1. This is equal to a quarter, just that. So 2 sine squared is equal to a quarter plus 1 and sine squared. So sine squared will be equal to 0.625. You're going to square root the whole thing, so you can cancel out the square here. The square root of 0.625. Don't forget the plus minus sign. And you will have sine theta is equal to negative 0.625 because your inequality, your boundary is shown. Your theta is negative 52.2 degrees. Find the x-coordinate of A. Notice that A is one of the points of intersection between the graphs sine x and 2 cosine x. So you will equate those graphs with each other. You will have sine x is equal to 2 cosine x. Now you can divide both sides with cosine x. So you will get sine x divided by cosine x is equal to 2. And you can substitute tangent x to the left-hand side of the equation. You will get tangent x is equal to 2. And x will be equal to 1.107, which is 1.11. Find the y-coordinate of B. B is the other point of intersection, so you have to find the x-coordinate first from the x-coordinate that you got earlier. To do that, you can just subtract pi from the value you got earlier, and this will give you negative 2.03. This is your x-coordinate of B. So just input this value into the x component of one of the graphs. I will use the 2 cos x. So you will have 2 cosine negative 2.03, and this will give you negative 0.895. Depending on what you got here, you will also get negative 0.894 or negative 896. That depends on the value here. The tangent to the curve y is equal to x cubed minus 9x squared plus 24 minus 12 at a point A is parallel to the line y equals to 2 minus 3x. Find the equation of the tangent at A. To do this, you need to find the derivative of the curve. So dy over dx is equal to 3x squared minus 18x plus 24. Since you know that the tangent is parallel to the line 2 minus 3x, you can just use the gradient of this line for dy over dx. So negative 3 is equal to 3x squared minus 18 plus 24. This will give you x squared minus 6x plus 9 equals to 0 multiplied by 3. So I factorize the 3 out. And your values are x minus 3. So your point A has an x coordinate of 3, but you still do not know the y coordinate. So go ahead and find that y coordinate. Input 3 into the curve's equation. Y is equal to 3 cubed minus 3 squared plus 24 multiplied by 3 minus 12. This will give you 6. So A is 3 and 6. Next, you will find the equation of the tangent. So y minus 6 is equal to negative 3, x minus 3. This is your gradient that you got earlier. In order for a function to be an increasing function, the derivative must be larger than 0. So the derivative of this function is 3x squared minus 18x plus 24. Now factorize the 3 out. And this will be larger than 0 because it's an increasing function. We'll get x minus 2 and x minus 4. This is larger than 0. And your values are x is equal to 2 and x equals to 4. Now draw a number line. and this will be 2 and 4. Now choose a number below 2. I will choose 1, and I will substitute the x in the equation with 1. I will get 4, which is a positive number, so I'll write positive there. Now choose a number between 2 and 4. I will choose 3. That is negative, which a negative 3 is a negative number, so negative in the middle, and I know that this is a positive number. Inequalities are x is smaller than 2 and x is larger than 4. Because you need a positive number in order for it to be increasing. Since I'm looking for x is larger than k is 4 because both signs are the same. For the first question, you need to show that OE is equal to 1.6i plus 1.7j. So what you need is the value of OB, the vector OB, so that you can find OE. What you can do is to find the length of OB first, so you know the ratio between OB and OE. So the length is 8 squared plus 6 squared. This is shown by 8 here and 6 here. So OB is 10. Now since OB is 10 and OE is 2, the ratio of OE to OB is 2 over 10. Now you will need to find the vector of OB. You will get that by adding OA and AB. So 8i plus 6j. So OE is 2 over 10 of that. And that will be equal to 1.6i plus 1.2j. The formula is cosine BDO is equal to the scalar product of OD and BD and the magnitude of OB and BD. You don't know OD yet, so you can go ahead and find that vector. OD is equal to OC plus CD. That is equal to 1.6i plus 1.2j plus 7k. And you don't know BD yet, so BD is OD minus OB, which is 1.6i plus 1.2j plus 7k minus 8i plus 6j. This will give you negative 6.4i minus 4.8j plus 7k. I apologize for that, guys. So BDO is the cos inverse of that. Now to find the numerator, you can multiply the I component with the I component here, the J component with the J component here, and the K with the K here. So you will get 33 divided by the magnitude, which is the square root of 1.6 squared plus 1.2 squared plus 7 squared for OD. That will give you 53 multiplied by negative 6.4 squared plus negative 4.8 squared plus 7 squared for BD. That will give you 113. And your answer will be 64.8 degrees. The 1, function f is defined by shown for x is larger or equal to c, where c is a constant. State the smallest possible value for c. This is technically asking you for the turning point, and since you have a completing the square equation here, you can just write your turning point as the negative of this number, which is positive 2, and whatever you see there, so 2. You know that your turning point is 2, 2. Since you want c, and c is a value of x, you can just take the value of x, so c is equal to 2. In parts 2 and 3, the value of c is 4. So find the expression for the inverse of x and state the domain of the inverse. To find the inverse of the function, you can rewrite the equation as x is equal to y minus 2 squared plus 2, and make the y the subject of the formula again. So you get y is equal to the square root of x minus 2 plus 2. This is your expression for the inverse of x, so I will rewrite y as the inverse. Next, the domain of f inverse is basically the range of the original function, so you can find the range of the original function first. X minus 2 squared plus 2 when x is larger or equal to 4, since this is the c value now. And since this is the smallest number, you can just input that 4 into the x, and you will get 6. So the domain of f inverse is x is larger or equal to 6. Solve the equation ff is equal to 51, giving your answer in the form of a plus the square root of b. So write the equation. You will get, you can just equate this, so it will be 0. And you will have x minus 2 squared is equal to plus or minus the square root of 51 minus 2. You will get x minus 2 squared is equal to plus or minus 7. But since you're looking for the plus sign only, you can just neglect the negative sign. That will give you x minus 2 is equal to the square root of 7. And x is equal to 2 plus the square root of 7. So a is 2 and b is 7. Show that the x-coordinate of a satisfies the equation shown, and find the exact value of the second derivative at a. What you want to do first is to find the first derivative of the curve y, and dy over dx is equal to, and equate that to 0. You will get 1 over x plus 1 squared is equal to 2x plus 1. And you will get 1 is equal to 2x plus 1 cubed. That will give you x is equal to the cube root of half minus 1. Next, find the second derivative, d square y over dx squared is equal to 2 plus 2 x plus 1 to the power of negative 3. When x is the cube root of half minus 1, which is what we got earlier, d2y over dx squared will be 6. Find, showing all necessary working, the volume obtained when the shaded region is rotated through 360 degrees about the x-axis. Since it's about the x-axis, you have to find the y square. So y squared is this will give you x plus 1 to the power of 4 plus 2x plus 1 plus x plus 1 to the power of negative 2. Now you have to multiply pi by the integration of y squared. Your limits are 1 and 0. It's 1 and 0 because it's 0 here and it's 1 here, and you're only asked for the volume between that. Now write the whole thing. Dx. This is equal to pi (1, 0). Now substitute x with the number 1, so you will have pi this will be minus pi of 1 to the power of 5 divided by 5, 1 squared plus 1 to the power of negative 1, and that will give you 9.7 pi. Don't forget to hit like and subscribe. See you next time.